All right, so here we're going to talk about 3.1 extreme values. So we are often interested in the largest or the smallest values that some function gives us. For example, you might want to know the fastest or slowest speed of an object. Like if you're throwing a ball or shooting a projectile or whatever. Okay. Also, you might want to be able to maximize your revenue. You're running a business. You want to figure out, okay, how in the world do I maximize my revenue? Well, usually that's just revenue is the price of the item times how many items there are, right? So just make as many items as you can and sell as many as you can. You maximize your revenue, right? Well, sometimes the cost that goes into making those items is a lot higher or potentially a lot lower the more that you make. So there's all sorts of variables that go into that. So not only do you need to maximize your revenue, you need to minimize your costs. Okay, and sometimes a function of minimizing your cost is more important than maximizing your revenue when we're talking about business. Okay, so let's talk about a definition here. Now, extreme values. So let f be defined on an interval that contains c. All right, so if we got this interval I, okay, and somewhere in I there's this c value, okay. F of c is a minimum, so f of c is a minimum of f if f of c is less than or equal to f of x for all x in the interval. So what does that mean? That means that f of c, the output f of c, is the smallest value in this interval here, okay? So that means for any other f of x, for any x in this interval here, f of c is less than or equal to f of x. So that would be an absolute minimum on that interval there. Okay, so that's number one. So number two is the opposite of this. Instead of being an absolute minimum, it's an absolute maximum. And so f of c to be an absolute maximum, f of c is greater than or equal to anything on that value. So your input here, all right, f of c here, is greater than or equal to any f of x where x is some value in this interval here. Okay? So that would be the absolute maximum. The maximum and minimum values are known as the extreme values or extrema of f on the interval I. Okay? So let's talk about a theorem. So a theorem, a result of this definition, okay? The extreme value theorem, very important theorem here. We talked about the intermediate value theorem. There's three big theorems in Calculus 1 that you really should know walking out of Cal 1, all right? So the big three theorems are the intermediate value theorem, the extreme value theorem, and then something we'll talk a bit later about called the mean value theorem. Okay, it's real mean, right? Okay, so those are the big three theorems, and then you get down to the fundamental theorem of calculus, and so those are kind of the big theorems of this class. All right, so what is the extreme value theorem? Remember, the extreme values are those maximum and minimum values on some interval for a function. So let f be continuous. So it's very important that f is continuous and then it's defined on a closed interval. If it's defined on a closed interval, then f has both a maximum and a minimum. So this is an existence theorem. So what this says is as long as we've got a closed interval for a continuous function, then it's got to have a max, it's got to have a min. How does this example here fail the extreme value theorem? Because it's an if-then statement, right? So if this thing is true, then what follows, right? So if the above is true, then what's in green here will follow. There has to be a max and a min. So what's not true about this picture here? Well, it's not on a closed interval. How do I know? This side over here is open and this side is closed over here. So that's not a closed interval. So when I look at this, it looks like the graph does have a maximum. The maximum is attained right here at x equal to 2. I have an output of 3. So the maximum of 3 at x equal to 2. However, like this side over here is higher than that side over here, but the problem is why I don't have a minimum there is because I can get infinitely close to 1, but I can't ever really touch it. So if you thought about this, okay, like if I could plug in like f of 1.00001, and that's small, right? That's like really close to this here. But the thing is, I could also plug in f of 1.0000001, and this would actually be smaller because the further I go this way, the smaller my outputs of f get, right? So I can never get the smallest one because it's an open interval, so I can get infinitely close to this 1, but I actually can't touch it, okay, because it's an open interval. So that's kind of why it falls apart. All right, so you can kind of think of it that way. So there is no minimum on this interval because it's an open interval. It does not satisfy the theorem. It has to be a closed interval. This is an open interval. Okay, so that's why it falls apart. Now this example here, it's even worse. It's open on this side and it's open on that side. So not only do we not have a minimum, but we also have no maximum. This thing has no max, it has no min. Okay, there's on this interval from 0 to 3, the open interval here, there's no max and there is no min value. It needs to be not only continuous, meaning I can draw the curve without picking up my pencil or pen or whatever, but not only that, but it also has to have closed endpoints, okay, for the curve. Now let's consider the function f of x, which is a polynomial. So we know polynomials are continuous on their domain. We learned that in the continuity section. And it's on a closed interval. So what does that tell me? By the extreme value theorem, we got a closed interval and a continuous function. So it has to have a max, it has to have a min value on this interval here. So let's try to find those values. So here's the graph here. Now I didn't extend this to go up all the way because it just keeps going up forever. So just let's pretend like this is the point here, okay? Now I want to find the maximum, I want to find the minimum. When I look at this, it looks like there is an absolute maximum because we have closed interval and a continuous function. Now, where does the minimum look like where does the maximum look like it's going to be? It looks like it's going to be up here. And the maximum is 9. How do I know it's 9 here? Well, what's on the edge of this interval? The further I go this way, the closer and closer I get to the highest value, right? So the edge of that interval is the 3, so I plug a 3 in to my function here to figure out the output. So f of 3 equals 3 cubed minus 2 times 3 squared, and that gets me the 9 that you see here, 27 minus 18. Okay? Now, same thing for the minimum value. The minimum value looks like the smallest part of the curve is right there. If you think about the curve, it's defined on this right here. It's only defined for these values. So that's going to be negative 20 over 9 at what value? Well, that value right now, we don't have a way of figuring that out except through a calculator. In a later section in this chapter, we're going to figure out how to find this x value here, okay, that x equal to 4/3. So for now, we're just taking this and we're graphing it, and we're going to use our graphing calculator. It's pretty easy to find max and mins. So I can actually show you how to do that real quick. Calculator, skip for now. Okay, let's see if I can graph this. So let me graph this. So the function was x cubed, and then minus 2x squared, enter, and I'm going to hit graph. Now, I want it on 3. Well, it's already set up to be like over here is 3, and then it looks like right there is a minimum. So what I'm going to do to find a minimum through my calculator is do second calc, and I'm going to go to minimum, and then I go on the left side of where I think the minimum is, and I go on the right side of where I think the minimum is, and then it calculates it for me. And it tells me right there the point P1 in the bottom left of your screen on the calculator. It says 1.333326. Well, technically that's a calculator rounding error there. Okay, that's what technology does for you, but it is exactly 4/3. Okay, so and I'm going to show you how to find that answer by hand with your with calculus, which should be pretty cool. All right, it has to do with slopes of tangent lines. All right, now what else do I know? I know that like as I go this way, the function only increases. So I'm just going to go to the band. I'm going to go to where x equals 3, and when x equals 3, oh, that's close enough, right? You can see that that's going to output a 9. Okay, I think maybe like if you did table, let's see, second table. Yeah, if you see x equal to 3 outputs a 9 there. Okay, so that's another way to look for maximum min values if it's going to be like a whole number or something. Okay, it doesn't always work that way. All right, but that's how you find the max and the min there. So hopefully graphically it's pretty easy to spot, hey, that's a minimum, hey, that's a maximum. In a future video, I'm going to teach you how to figure out using calculus these exact max and min values. All right.